Hello friends, today we are going to look at the problem move zeros, which is problem number 283 on LeetCode. As always, let's read the problem statement and try and understand what the problem really wants us to do. Given an integer array nums, move all the zeros to the end of it while maintaining the relative order of the non-zero elements. Note, you must do this in place without making a copy of the array. So right off the bat, we are given a list which contains integers, and we are supposed to move all the zeros in this particular list to the end. And we need to maintain the relative order of the non-zero elements. Also, we need to do this in place. So if we take a look at this example, we're given a list of 5 elements, 0, 1, 0, 3, and 12. Both these zeros need to go to the end, and the order of the elements, order of the non-zero elements, 1, 3, and 12, needs to be maintained. Now, in case we are given a array or a list just with 0, then it's going to be the same output. And we're also given some constraints where it says that the length of this particular array or list ranges from 1 to 10,000. And the elements themselves can be from this value to this value. So there could be negatives and positives. Now, coming to the thought process behind this, if we just whiteboard this, so if I just write down the particular array elements, so we have 0, 1, 0, 3, and 12. Now, one thought that does come into mind is that can we simply sort this particular array? But then sorting is going to destroy the relative order of the elements, because in case 12 comes before 3, then that's not going to work. Now, another approach that we can take is to use a slow and a fast pointer approach, where I can start my slow pointer here and a fast pointer out here. And we compare the elements, saying that if at all the slow pointer and the fast pointer both are equal to 0, then I only increment the fast pointer. In case the fast pointer is not 0 and the slow pointer is 0, then I do a swap operation. So in case of the swap operation, this becomes 1 and this becomes 0, and I increment both. So then fast comes out here and slow comes out here. And in case both slow and fast pointer are 0, I do nothing. There's no swap operation. I just simply increment the fast pointer. So fast pointer will start pointing to this location. Now again, we have a 0 here and a 3 here, so I do a swap. So this turns out to be 3, this turns out to be 0. And I again increment the fast pointer and the slow pointer. Slow comes here, fast points out here, and again do a swap. So after this, I will be landing up with 1, 3, 12, 0, and 0, which is what I'm going to return. And this is the final output. One thing to note is that this is going to take a time complexity of O of n, as I'm simply going to scan the elements one by one and perform a swap operation. And this is an in-place operation, as I'm not creating any other array or list or dictionary or any other kind of data structure. Now that we have the thought process in mind, let's start coding the solution up. So here I have my code pad. So initially what I'm going to do is I'm going to create a length variable, which is the length of the nums list. After I have my length, I'm going to initialize a slow and a fast pointer. Both of them initially point to the first element. So both of them will point to this. Now, what I do is I start a while loop where the fast pointer, as long as it's less than the length of nums, it is going to go on. Now I start my comparison operations. So there will be 4 comparison operations. The first one will be where both slow and fast both are 0. That is, the elements are 0. In that case, we increment the fast pointer. So we increment the fast pointer. Then slow is 0 and fast is not 0. So we do the swap and increment the slow and fast. Then there is a case where fast is 0 and slow is not 0. So we increment slow and fast again. And the last case where fast is non-zero and slow is also non-zero, where we again increment the slow and the fast. So I'm going to write all the 4 cases separately so that we get to understand what the code is. We can definitely combine some of these steps, but in order to just clearly explain what they are, I'm going to write each of them separately. So coming to the first case, we will have if nums of fast equal to 0 and nums slow equal to 0, I just increment the fast pointer. Else if nums fast not equal to 0 and nums slow is equal to 0, I do a swap operation. So in Python, the swap operation is very easy. All you have to do is num slow, num fast is equal to num fast, num slow, and the swap operation is complete. So that's the swap, and I increment my slow and fast pointer. Else, if nums fast equal to 0 and nums slow not equal to 0, I again increment the slow and the fast pointers. And the last case where nums fast not equal to 0 and nums slow not equal to 0, again increment both the pointers. And I'm done. So as mentioned before, you only have a single while loop which goes over all the elements of nums. So this means that the time complexity is going to be O of n, where n is the number of elements in nums. And we are not using any extra space besides declaring some variables. So space complexity would be O of 1. Let's run this code for a sample test case. And the sample test case is 0, 1, 0, 3, 12. And as we see, the output is what we intended to be. Let's try with some other test cases. So how about we just put a single number here of 0, for which we get the output as 0. We try another test case. So here I have 1074. I'm getting 1740. So the order of the elements has been maintained and 0 has been pushed to the end. And I'm going to try one more test case with negative numbers as well. So I'm going to make this -7, -6, And we have the output as follows, where the order of the elements has been maintained and 0 has been pushed to the end. I'm going to go ahead and submit the code, and our status has been accepted and the solution is passed. Thanks for watching the video, and do subscribe and let me know what you think in the comment section. Thank you.